Hey students, it's me again. This time I'm in a different spot. You might recognize this. It's been a while, but this is our classroom. I finally decided to come in and do some work here, and I thought I'd shoot a video while I was here. So I'm kind of excited about this because we're going to be doing some Catapult work, an activity that we would have gotten to do if we were together, but unfortunately we aren't. So I'm going to show you some things here for our instruction today. So let's get to it. All right, so I tried to get as much of this set up as I could. So what I have here is a catapult. This is one that I made from a mouse trap. Mounted it to some wood. Normally I have the students make their own, and if they can't build a good one, then I end up letting them use some of the older ones that I have. So what the task first in this activity was to take your catapult, and you had to build it so that it launched a projectile really about 1 to 2 meters in distance and no more than 1 meter in height. Okay, so I wish I had like a slow-mo zoom in so you could see this, but I don't. So I'll just launch this here and see if you guys can see it go. Landed about there, so you can kind of get an idea of the parabola that it just followed. Okay, now what we've been doing is we've been talking about an equation that represents, as time goes on, what is the height of this projectile. Okay, so we've been doing these equations like the height as a function of time, if you can see this, where it's we talked about in feet, it was -16 t squared plus the initial velocity times t plus the initial height. Okay, so that's what we've been doing. Today, though, with this activity, we're not going to use that idea of a height, as a time for our input, okay? So it's still a quadratic function we're going to look at, just not with the time variable, okay? So instead of the time variable, we're actually going to use the horizontal distance for our x and our vertical distance for the y. So what you would have done in this activity is you would have gotten together in groups and you would have launched your projectile many times, collecting data, one of which was at its vertex, how high above the ground was the projectile, where did it hit on average, and ultimately think about where it's starting at. Is it starting at 0, 0? No, I'm starting my x-axis at 0, but my y-axis is about 15 centimeters, the projectile is about 15 centimeters when it launches, okay? So you would create this picture. The y-intercept was 0, 15. Your vertex, I've already done these calculations to save some time. The vertex was 53 centimeters down the way, horizontal, and it was 52 centimeters high, approximately. And then at the end, it landed at 109 centimeters, and obviously the y value was 0 there. Okay, so you would take this data, and then you would simply use Desmos, like we've done in the past, put in a table, and, okay, so we'd come here, we would, oh, I left my markers over here. We would put these ordered pairs in a table. Right, remember a table? X1, Y1. You put those in, and then Desmos gives you this graph, and then remember how you can type in Y sub 1, then squiggle A x sub 1 squared plus B x sub 1 plus C, and it will give you the A, B, and C. It's like a regression equation, except this time we're doing it for a quadratic. So it will draw the parabola in there, and it'll give you the formula. That's the formula that you get from Desmos. Okay? So that would have been the first part of your task. And for right now, you don't really need to do that or replicate that. You just need to know how to use it. And so that's what I want to talk to you about now. So over here, let me just remind you of this first. Okay? Y is our vertical distance from the ground. X is the horizontal distance not above the ground. The horizontal distance from where we start to where it lands, okay? And there's our function again. And so one question that, and the thing that's kind of a bummer about this, we would do like a competition, right? So we do these 3 competitions to see which group actually has the best catapult and has the best math work to go along with it to be accurate. But here's what we would do. The first thing is we would take our catapult, quick tour of the room. Don't you guys miss being here? Okay, miss all this fun stuff? I don't know. For me, I just got a huge boost of energy just coming in here today. Yeah, it's just a bummer we're missing out. Okay, so what we would do is the first activity or challenge, we would say, all right, your catapult has to be 60 centimeters. Its launch point 60 centimeters from a wall. You do the math. You don't get to practice this ahead of time. You do the math and you tell me how high up on the wall I should put a bullseye. So when we launch it, can your projectile hit the bullseye? Okay, so how would you do that? Okay, what would be the math for that? Hopefully you can see this okay. Well, think about it. We're given an X value, right? So all you're gonna do in this case is plug the 60 centimeters in for the X. And solve that. I didn't solve this ahead of time. Let's quick try it here. 3,600 times negative 0.0149 plus 1.489 plus 15. 50.7. Okay? So you would want to put that target exactly 50.7 centimeters off of the ground to hit the bullseye. That was challenge number 1. Challenge number 2. There's my amazing catapult. But this time, we have to figure out a horizontal distance, and I'm giving you a height to land at. Normally I set like books, and I set a target on top of the books that's 40 centimeters tall. And then I say, all right, how far away should your catapult go? Well, again, let's look at our equation. Negative 0.0149 x squared plus 1.489x plus 15, right? So what do we do here? Well, hopefully we recognize that they're giving us a y value. So that y value, you see this okay? That y value has to go in for y. So we have this value here. Okay, how do we solve that? Well, we're solving for x, so this is going to require either factoring or the quadratic formula, and I think we would agree with these sorts of decimal numbers, the quadratic formula is going to be the way to go. So we start off by getting one side equal to 0. I should really check and make sure this is recording. Good. Minus 25. And then from here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay? That's going to take a little while to punch out, right? But we would get a number. We would actually get 2 numbers, only one of which would make sense, right? Think about your parabola here, okay? One of those numbers is going to tell us this value. The other one's going to tell us when it hits 40 centimeters on the way up, right? So we got to realize that there's 2 times that it goes through a height of 40 centimeters. One's going to be pretty early on. We don't want that one. The other one's going to be further on down here. That's the one we want, okay? That's the x value we want. So we could get that by doing that, okay? The final challenge was going to be just where's it going to hit the ground? Where am I going to set the target, okay? So that you hit it. What's the horizontal distance? So it's the same as this, except instead of putting 40 in for y, you're putting 0. Okay? So that's it for now. I can't think of anything else I was going to do for that one. You can expect us to practice one of these at some point next week. And yeah, you'll probably get another video too. So good to see you guys. Have a good rest of your day.